Venus is the closest planet to Earth. At the beginning of the solar system, it was actually more suitable for life than Earth. But that was 4 billion years ago. Venus is now 460 degrees. The atmospheric pressure is equivalent to thousands of miles deep in the ocean of the Earth, plus clouds of sulfuric acid floating in the sky. Totally a hell planet. But astronomers don't think he's actually fully dormant. In fact, it was a long time ago. Scientists have noticed that the surface of Venus looks very young. If you compare the number of craters he has to Mars, Mercury and the Moon compare, you'll find millions of craters on those planets. Those dense potholes, they're the result of asteroid or meteorite impacts that accumulated over billions of years. In comparison, there are only about 1,000 craters found on Venus, and one wonders if Venus has a thick atmosphere. To stop the flying gravel, but even with such a thick atmosphere, it's impossible to block every big meteorite that hits in as long as 450 billion years. No matter how you look at it, there is still a chance for larger meteorites and asteroids to rush in, leave more potholes in the surface. Could it be that these craters, did they all slowly disappear one by one? After all, Venus's atmosphere is no ordinary mixture of air. It's 55 times more concentrated than Earth, maybe even a little breeze. It grinds away the ground like a sandblaster, slowly smooths the edge of the crater like sandpaper. Polishing, or even the whole thing may be polished. About 50-60 kilometers above Venus. That is, there is an area of sulfuric acid toxicity. The wind speeds there can actually reach 360 kilometers per hour. But it falls to the surface. Where these craters are, things are completely different. The average wind speed over there is only 0.3 meters per second. Converted to an hour, it's only a little over a kilometer. This level of wind, it's hard to say it's a breeze. It was almost as quiet as no wind at all. So the atmosphere or the wind, there's no way to explain why there are so few craters on Venus. That leaves only one possible explanation. The surface of Venus has been renewed. And the time of this update, if you look at the geological time, it's actually very, very recent. To the surface of the Earth is to be constantly blocked by rain. There is also the wind part updated by crustal changes. We've already mentioned that. And on Venus there is no such thing at all. So, what are the possibilities of the Earth's crust changing? There's no evidence of tectonic plate movement on Venus. Even if there is, it's only very, very faint. Almost no impact. The reason for this situation, in fact, two things can be summarized. First, the crust of the Earth is made up of many moving plates. They move towards each other. Push staggered. That's why the terrain keeps changing. But the elaborate shell is a single lithosphere. Completely different. Secondly, the Earth allows the plates to move in this way. It's because water acts as a lubricant. Venus has no water at all. So here's the problem. Why is Venus so special? And the answer is volcanic activity. In fact, about 75% of the entire surface of Venus is covered by the plains of face. There are thousands of volcanoes on Venus. Some of them are huge. It's a giant volcano. And here's what's extraordinary. There are other planets on Venus, strange terrain that has never been seen before. It's made of thick lava that flows outward like a pine dome. A structure formed by circular flattening. There are also silk-like fissures called spiderweb formations, and the kind of circular terrain that seems to be propped up from the ground. It's called the coronal structure. These are all unique landscapes unique to Venus, After all, it is volcanic activity that dominates the overall appearance of Venus. Completely reinvented it. But here's the problem. When did the volcanoes on Venus erupt? And will they continue to operate now? To this question, well, there are two main theories. The first is called the mass upheaval theory. It means that Venus was at some point in time. The entire planet was almost completely turned upside down. A lot of magma was erupting from the ground. The original surface and crater were all covered up and disappeared. Some people think that such a sea change is caused by the careful accumulation of internal heat to the limit. After all, in the absence of crustal change, heat energy cannot be effectively discharged at all. The second theory holds that, and this is happening incrementally, volcanic activity progresses slowly over hundreds of millions of years. Local eruption. Little by little, the whole surface changes. In either case, Venus is what it is today. It's all geology playing a decisive role. And the entire evolution of Venus. To put it bluntly, how is the internal heat energy redistributed? Add to that the accumulation of greenhouse gases. Having said that, for us Earthlings, rather than studying the geological activity of Venus, perhaps more concerning, Venus and Earth are so similar in mass and distance from the Sun. Why did life on these two planets take completely different paths? Venus is also depicted in habitable proxies. Then why did it end up so desolate? What are the key factors? Pushed Venus into hell, but made the Earth a paradise for nurturing life. And here's what's even more disturbing. Will the Earth one day follow in the footsteps of Venus? Become another hellish planet? And of course, distance from the Sun is crucial. But that was just the first match in the chain reaction. According to speculation, early Venus would have had Earth-like water resources. However, since Venus is closer to the Sun than the Earth, received nearly twice as much solar radiation as the Earth. As a result, the water began to evaporate a lot, and water vapor itself is one of the very potent greenhouse gases. Huge amounts of water vapor heat the atmosphere, further exacerbate the evaporation of water. It creates a vicious cycle, and this is what we call the runaway greenhouse effect. The entire climate system collapses. Out of control. Over time, water begins to be broken down into hydrogen and oxygen by the Sun's ultraviolet rays. Venus lacks magnetic protection. This allows the solar wind to be easily blown away into space. Light hydrogen fades away easily. The remaining oxygen combines with minerals in the rock. So there's less water, less and less, until it's almost completely exhausted. A planet without water, the most important carbon cycle system for climate regulation, is lost. On Earth, carbon dioxide will be carried into the ocean or sedimentary ice. But on Venus, he remains in the atmosphere, and it adds up with a creepy speed and scale. And it got worse. Venus has no plate movement to help remove heat. The internal heat continues to build up. More carbon dioxide is emitted with volcanic activity. Eventually, the entire planet's atmosphere becomes a thick layer. It's almost a pure carbon dioxide blanket. The current air pressure has reached 92 times that of the Earth. The surface temperature is a terrifying 460 degrees Celsius. Such an environment. It's no exaggeration to say he's hell. But did everything on Venus really end like this? This next bit is really intriguing. According to data obtained by the space probe Magellan in the 1990s, and later infrared observations, there is evidence that volcanic activity on Venus likely did not occur until recently. Calculate through analysis. Some facial tumors may have formed only a few million or even hundreds of thousands of years ago. In geological timescales, that's almost like what just happened yesterday. In a study published in 2023, scientists compared two images of the same location taken 8 months apart in 1991. The analysis results revealed that new traces of lava flow had appeared in the middle. In other words, there's still volcanic activity on Venus. The simulation results also show that at least 37 coronal tectonic regions have remained active in recent years. In addition, gas components associated with volcanic activity, such as sulfur dioxide, have also been detected in the atmosphere of Venus. And here's what's even more interesting. Scientists have discovered that there may be some kind of thermal convection going on inside the crust of Venus. This convection allows the subsurface to boil internally. Even without plate motion, it still has the ability to push faces to the surface. Combining this evidence, Venus probably hasn't really died yet. To say the least, he's not completely inanimated. Venus reminds us, the balance of the planets is actually very fragile. As long as one key link goes wrong, can embark on a path of destruction that cannot be turned back. Even if we find another Earth in another star system, we can't immediately tell if it's heaven or purgatory. And Venus is a perfect example of how we can learn to tell the difference. But here's the thing. Venus allows us to witness with our own eyes. Earth could have gone to another fate. It happened right next door to us. After all, the distance between Earth and Venus is actually only 40 million kilometers.